In this video, we're going to talk about an introduction to quadratic formula. So we're going to talk about the discriminant and how we can use that to understand how many real roots we have in a specific quadratic function. Also be able to state the quadratic formula from memory, be able to solve using the quadratic formula, and then also simplify if we get square roots that do not have perfect squares, and how to deal with that when we have a negative in the square root. So first off, we need to make sure that our equation is written in standard form. So we have to set it equal to 0. We have to have it laid out 8x squared plus bx plus c, because we need to use the a, b, and c value in our equation to plug into our quadratic formula. Okay, and remember that we're still using some different techniques to solve for x, which represents the roots in our quadratic function. Okay, so if we're not able to factor it, if we're not able to complete the square, kind of our last resort is to use quadratic formula. So the discriminant is a specific part of our quadratic formula. It's what's underneath the square root. So it's b squared minus 4 times a times c. So we need the a, b, and c value from our equation to evaluate the discriminant. If it is a positive number, or it's greater than 0 here, then that means that we're going to have two real roots. Our graph is going to intersect the x-axis in two places. If our discriminant is 0, well, then we're only going to have one real root, right? So if we think about the square root of 0, it's not going to be plus and minus a certain number, because there's no positive and negative 0, it's just 0. So we're only going to have one root there. If our discriminant is negative or less than 0, then we have 0 real roots, because that's an imaginary number, but that is going to give us two complex roots. So it's going to be two roots with a complex number. So let's go ahead and look at some examples. Our equation is already set up in the form we need it to be. So our a value is 1, b value is 5, c value is 4. It's always our first step. Make sure we've got standard form, set it equal to 0 so we can figure out a, b, and c. Now our discriminant, this is, again, going to tell us the number of roots we should have, and it kind of breaks our quadratic formula up into a couple chunks. Okay, so remember our discriminant is b squared minus 4ac. So we take our b value 5 squared minus 4 times our a value 1 times our c value 4. So we end up with 25 minus 16, which is 9. That is a positive number. So since it's positive, then we're going to have two real roots. Okay. So now if we go to our the rest of our quadratic formula, x equals negative b. Our b value is 5, plus or minus the square root of b squared minus 4ac. But we already figured that out. We already solved, and we got 9. Okay, so we can just substitute that in. Then we divide by 2 times our a value, which is 1. Okay. So now let's just simplify this. I can drop the parentheses around the 5 and just becomes negative 5. Plus or minus 9 is a perfect square. So we get plus or minus 3 divided by 2. All right, we would like to simplify this a little bit more. All right, this is technically negative 5 plus 3 over 2. And negative 5 minus 3 over 2. So the first one, we get negative 2 over 2, which simplifies to negative 1. The second one, we get negative 8 over 2, and that simplifies to negative 4. So x is equal to negative 1 and negative 4. Those are our two real roots. Okay, that's a nice one because we get integers for our answers, but we're not going to always be that lucky and be able to simplify our radical. So, next example. Remember to always pause the video and try it yourself before taking a look at the answer. So this one I do not have my equation equal to 0. Right? So we need to subtract 11 on both sides. So we're going to get a squared minus 8a minus 11 equals 0. And now I have the correct a, b, and c value. So 1, negative 8, and negative 11. Notice how this equation had an a instead of an x. Right? Our previous one had x. That's typically what we see. Just because there's a different variable in there doesn't change any of the steps we need to do. Okay? All right, so we got a, b, and c. We can do our discriminant. Right? Remember, it's b squared minus 4ac. So I have to do negative 8 squared minus 4 times a times c. Be careful if you are doing this in your calculator. You have to put these parentheses around the negative 8. If you just type in negative 8 and then to the power of 2 like that, it's going to just take 8 squared and then make it negative, so you have to put parentheses around it. So that gives us a positive 64. Negative 4 times negative 11 is a positive 44. So we get a positive 108 for our discriminant. It's another positive number. So we get 2 roots. Go to the rest of my quadratic formula. I start with negative b. Well, b is already negative, so that's going to eventually become positive. Plus or minus the square root of our discriminant, which we already found to be 108, divided by 2 times a. Okay, so negative 8, that's like a negative 1 times negative 8, that becomes positive 8. Okay, 108, now that's not a perfect square in itself, so we have to think about, can we factor out a perfect square? 108 is kind of a bigger number for us to do in our head, but if you play around with that with guess and check or with a calculator, you can find that this factors into 36 times 3, and 36 is a perfect square. Right? Square root of 36 is 6. So this simplifies to 6 root 3. So even though we have a radical in there, it's not a complex number, right? We don't have an I, so we still have 2 real roots. We just don't know what the exact value is because we're going to leave that radical there. And then divide by 2. The last step here, now we could stop here, but we'd like to simplify it. Okay, there's technically 3 terms. Once we simplify everything, okay, it's that negative b value, it's whatever our discriminant is simplified, and then our denominator. Okay, so if the b value, the 8, or negative b, I should say, and the coefficient of the radical, if we still have a radical, if those can both be divided by our denominator, then we can simplify it that way. Okay, so we can do 8 divided by 2. Oops. 8 divided by 2 is 4, and we can do 6 divided by 2 is 3. So this becomes 4 plus or minus 3 root 3. So we still have 2 real roots, but we've got a radical in our answer. All right, another example here. We have to subtract that 4 over to the left side to get it equal to 0. Okay. Recall that when we do complete the square, the way this equation is set up, we're good to go. But with quadratic formula, we need everything on the same side. Now you could, because we have all negatives there, and maybe you prefer to work with positive numbers, you could move everything over to the right side and have the left side equal to 0. So our A, B, and C value are going to be different, have different signs, but it's still going to get us the same answer in the end. Okay, so I'm just going to stick with what we have here. Our discriminant, b squared minus 4 times a times c. So here we got a positive 16. Now we got negative times negative, which becomes positive, times another negative. And we get 16 minus 16, which is 0. So if we have a discriminant of 0, remember that gives us just one real root. Okay. So this is going to be a little easier to simplify. So we've got negative b. Again, our b is already negative, so that's going to become positive. And we're taking square root of 0. Divided by 2 times our a value. So we get a positive 4 now. Square root of 0 is just 0. So I don't even need to write that. It's going to be a 4 in the numerator. And the denominator is negative 2. That simplifies nicely to negative 2. Okay, so there's our one real root. Last example, what if we end up with a negative discriminant? So here we have a B, and C value right there. So our discriminant is going to be b squared. So 2 squared minus 4 times a times c. So we end up with 4 minus 16, which is going to be negative 12. All right, so we're going to have 0 real roots. We're still going to have 2 answers, but it's going to be complex. Okay. So x equals negative b plus or minus the square root of our discriminant, negative 12, divided by 2 times our a value. Okay. So now we get negative 2 plus or minus, and now we got to simplify that square root of negative 12. I kind of like to simplify some of these other steps first, so that I can just focus on my radical there. I'm going to bring this over here. I can break down my my negative 12 into square root of negative 1 times square root of 4 times square root of 3. Right? We're looking to factor or take out a negative 1 if we have a negative there, and then factor out any perfect squares. 4 is a perfect square and is a factor of 12. So remember, this gives us our imaginary number I. This is a 2. And then the root 3 stays as is. And then we just need to rewrite it. So it's 2I root 3. Okay, so I get negative 2 plus or minus 2I root 3 all over 8. And remember, the only way we can simplify this fraction here is if the coefficient of our radical there and our first constant number there can both simplify with our denominator. They're all even numbers, so we can divide all of them by 2. So we end up with negative 1 plus or minus 1I root 3 all over 4. So there's an example with 2 complex roots.